Good morning, my dear friends. Now in the last class and all, we were seeing how to design a PSC beam or slab by using this Hin's method of design. Am I right now? And there we have seen the preliminary design as well as the final design. Okay. In the preliminary design, you have got various thumb rules or small equations. Okay, based on some scientific this thing. Okay, so in the final design, you are going to refine the section, as you know. Okay, so now in this class we will try to take up one problem on the design and we'll see how exactly it can be calculated. Okay, so all the things will be clear when we start solving the problem now. Okay, so now I will read the problem now. Investigate design of a pre-stress concrete section using Lin's method for MT is equal to 500 kilonewton meter. In a sense, he has given the total moment MT. Okay, total moment is 500 kilonewton meter, and he has given MD, in a sense the dead load moment MD is equal to 60 kilonewton meter. Okay, for the following. So these are this thing. Now he has asked you to investigate the design for a preliminary design. In a sense, you will have to do the preliminary design, and then B, design considering no tension. In the sense, as you have seen, by considering no tension in concrete, I have to design it. In the sense, it is the final design. Okay, by considering no tension in concrete. But now C, he has asked design by considering the tension. Okay, so now this is not there in your syllabus, so don't bother about this C part. Okay, so now we'll try to consider preliminary design as well as the design by considering no tension in concrete. Okay, so now this C part we are not going to tackle. Okay, so now and also he has given some more data. Assume FCCI. FCCI means it is now permissible compressive stress in concrete in initial condition as 15 Newton per mm square. FCCF means it is permissible compressive stress in concrete in final condition. It is 18 Newton per mm square. Okay, sir. Now, sorry, it is 13 Newton per mm square. And FCTI or FCTF, in the sense it is permissible tensile stress in concrete in initial condition or permissible tensile stress in concrete in final condition. FCTI or FCTF is equal to 1 Newton per mm square. These are the values he has given. And also he has given FPI. Okay, it is the allowable tensile stress in initial state. Okay, in the cable it is 960 Newton per mm square, and FPE, in a sense, it is the allowable tensile stress in steel in its final state. Okay, it is 800 Newton per mm square. So now for these datas you will have to design the section. Okay, so now as usual we shall begin the problem with our preliminary design now. So now first of all I will take the ratio of MD by MT because he has given MD also in the problem, MT also is given in the problem. Okay, so MD by MT ratio, if I take, it is 0.12, so it is a less than 0.2. In the sense, it comes under smaller MD by MT ratio. In the sense, case 1, as we have seen in the theory class. Okay, so MD by MT ratio is now 0.12. So now when MD by MT ratio is now less than 0.2 or it is small MD by MT ratio, then now we have some thumb rules by which I can calculate the depth of the beam. Okay, so if you see the various formulas or various thumb rules whichever we have seen, there is one equation. The depth can be calculated as D is equal to, it is overall depth, is equal to K root ml. Okay, K root ml. So now where K varies from 30 to 40. Am I right now? It is K root ml. Okay, so now ml means it is the live load moment. Okay, now so now live load moment ml can be now easily calculated as mt minus md. Am I right? It is a total moment minus dead load moment will give you this thing now. What now? ML, in the sense live load moment. I know MT, I know MD. So I can easily calculate the live load moment ML. Okay. So now also let us take the value of K as 40 because K varies from 30 to 40. Baba, you'll have to go to your preliminary design. There we have seen some of the thumb rules. Okay. So from those thumb rules, I have chosen this equation. Okay. So Baba, I know the value of K, I know the value of ML. So just put here now the values here now. Okay, you will get the approximate depth of the beam required. In the instance now, approximately I need 839 mm. Say, let us adopt 1000 mm approximately. Okay, so anyhow, it is a preliminary design. It is not an accurate design. Only thing is now, approximately we are going to fix up the dimensions here now. Understood? Okay, so D, I'm going to adopt it as now 1000 mm. Okay, so now since MD by MT ratio is now less than 0.2, okay, the required effective pre-stress is given by this equation. PE or FE is equal to ML divided by 0.5D. Baba, this is another equation you have seen in your preliminary design. Baba, some of the equations you will have to remember which and all are now going to come here now. You will have to remember. Okay, these are not given in the IS code. You have to remember it. Okay, so effective pre-stress can be now calculated as ml by 0.5d. But by ml I know ml is 440 into 1000 to convert it into Newton mm. 440 it is in kilonewton meter. Am I right? So now I am converting it into Newton mm. For Newton into 1000, for mm into 1000 divided by 0.5. D adopted is now 1000 because I am now assuming D is equal to 1000. So now approximately I need an effective pre-stress of 80 88,000 newtons. Okay, this is one thing now. Okay, next, but now in the same preliminary design, you have seen area of concrete AC can be calculated by this equation: PE divided by 0.5 FCCF. This is the equation again given in the preliminary design, which gives me area of concrete required. Okay, so PE I know, just now I have calculated effective pre-stress 0.5, and FCCF means it is permissible compressive stress in final condition. Okay, it is given in the problem, it is 13. Okay, so you can put it. So now I will get the value as concrete area required is so much mm square. Okay, this is one thing. So now also, now I want to calculate to carry this much effective pre-stress. Effective pre-stress is 88000. To carry this much effective pre-stress, how much is the area of steel required? How much is the area of pre-stressing steel required? AP. Baba, it is given by PE, this value, effective pre-stress, divided by safe stress in tendons, FPE. In a sense, it is the permissible permissible stress in tendons in the final condition. Okay, it is, Baba, it is also given, FPE value also is given in the problem. So PE value I know, it is 8800 divided by 800, safe stress. Okay, so PE by safe stress will give me this much. In a sense, this much area of steel I have to place in the beam. Okay, to carry this much effective pre-stress. Okay, so now 1100 mm square of tendons or cables, you will have to keep it. Okay, so but now still we have not taken one more decision whether I am going to provide a rectangular section or a I section or a T section. But now it is left to you. In the problem also he has not stated anything. Okay, so now it is left to you whether you can give a rectangular section or I section or T section. Okay, so but now let us go for I section only now, because I section is little complicated, as you know. So I will take this case only. Okay, let us provide an I section. But now when I want to provide an I section, again by using your thumb rules, The approximate thickness of the web can be calculated as d by 40 plus 100. This is another thumb rule we have seen. Okay, d by 40 plus 100. So d, you know, 1000 divided by 40 plus 100 will give me 125 mm as the thickness of the web. Similarly, approximate width of the flange. Width of the flange can be calculated by the equation, again by thumb rule, 0.6d. So 0.6 into 1000 will give me 600. And approximate thickness of the flange, it is given by 1/5 of d. So 1/5 of 1000, it is 200 mm. Okay, so now by using these thumb rules, you can fix up the dimension of this I section. Am I right now? Thickness of the web you know, width of the flange you know, thickness of the flange you know. So you can easily draw the cross section. Am I right now? So now by using this, now I want to calculate this area of concrete provided. Okay, cross sectional area of the concrete provided for this I section is, okay, you can easily calculate. You know the flanges 600 mm by 200 and web also you know 125 into this thing. So it will give me 31500 mm square. Am I right, sir? Now see now. Now in your previous calculation you have seen one thing. Am I right? 1 minute. Now you have seen that you need an area of concrete as this much. Area of concrete required is 135385. Am I right? 135385 mm square. Am I right now? But now you have given an area of 315000. Am I right now? 315000. Baba, it is a much greater than your 135385. In the sense, you are going to give much bigger area than this. So now it may become highly uneconomical. Understood or not now? So now you have to revise the section. Instead of this much area, I will reduce the section so that your I section becomes nearly to this. Okay, so now I am going to give an I section as shown in figure. I am going to reduce all these flange width. I am going to reduce. Okay, and overall depth I am going to reduce. Thickness of the web I am going to reduce, so that now I will get the reduced area. Okay, so for this, if I calculate the cross sectional area, you will get 150000 mm square. In the sense, it is just slightly greater than your area of concrete required. Am I right now? It is slightly greater than 135385 mm square. So therefore, I say that this cross section is okay for our preliminary design. Okay, so now this is how you have to do the preliminary design. Okay, so in the next class I will go to final design. Okay, thank you very much.